Alright, so the first thing I'm going to talk about is my position time graph, and that comes from tracker and the video we took of my car moving. And so we have a position time graph. And basically, the first curve curves upward, which matches the upward line for velocity time graph, which is my acceleration speeding up. And then it curves downward, which matches the line slanting downward, which represents the acceleration of the car slowing down. So we find the acceleration speeding up with the slope of the first line, which is 0.4437. And then we find the acceleration of the car slowing down, which is negative 0.7806. The second thing I'm going to talk about is the data we found. So, like I said, the acceleration speeding up is 0.4437, and the acceleration slowing down is negative 0.7806. So, for our first force diagram, which represents our acceleration speeding up, we have normal force in the upward direction and weight going down direction, which would be equal. Um, and then we have our friction to the right, which helps propel the car forward. When we add up our forces, our sum of forces is towards the left, and you find sum of forces with Newton's second law, which is mass times acceleration. Our mass is 0.18, and our acceleration is 0.4437. So your result would be your 0.0798. Okay, so for your force diagram for acceleration slowing down, it's the same thing except your friction is going the opposite direction because while my car moves in the positive direction, the friction goes in the opposite direction to slow it down. Um, so like I said, normal force is up, weight is going down, they're equal. And when you add up your forces, your sum of forces goes in the positive direction. Um, like I said, sum of forces is mass times acceleration. So your acceleration slowing down is 0.786, and you multiply that with your mass, which is 0.18. Therefore, your sum of forces is negative 0.1405. On the bottom left-hand corner, you have the energy flow diagram, which basically sums up the whole project. So at rest, velocity is at zero, and your E elastic is at max because the spring is down. Um, and then when you propel the car forward, you have energy dissipating and leads up to your kinetic energy. Basically, your E elastic is 1/2 kx squared. K is your spring constant, which you find with the torsion wheel. Um, so E dis would equal EK minus E elastic. So E elastic is 1/2 0.689, which is your spring constant, and 6.5 squared, which is your position squared. So you get 14.55, and you subtract that to kinetic energy, which is 1/2 mv squared. Your mass is 0.18, and your velocity squared is 1.457, and you get 0.1905. And then when you subtract the two, you get around 14. Your displacement is your delta x equals final position minus initial position. Your final position is 6.5, and your initial position is minus 0. Therefore, your um, displacement is 6.5. Uh, and the last part of the presentation would be my graph for my E elastic. So basically, the graph or slope would be 27.17 newtons per meters. And then to find your total force, you multiply your slope, which is 27.17, to 0.06 pi, and then you get 5.12, and then you add 1.092, which is the amount of amount between the amount of the shaded area underneath the triangle of the graph, and then you get 6.212, which is your total force. After that, I used 1.092 again, and I multiplied that to 0.06 pi, and then I got 0.206 joules. And then you add 0.483 joules, which comes from 1/2 times 0.06, and then you add it, and your total energy will be 0.689 joules. So that's it for my mouse